sometimes is useful to take derivative of the derivative. Call this the second derivative. Find the second derivative of this. Let me take the peak of this. Okay. Further, find the second derivative of the following functions. Okay. Yeah. Further. Okay. Further. Okay. Yeah. Further. Okay. So first, we'll start from here also. So first, let me discuss these three questions. First, I will tell one question and then you can. Hmm. So we have to find the second order derivative of this question. This first question is fx equal to x to the power 4 plus 3x square minus 5x to the power 1 by 2, right? This is the first question. And what is second order derivative? Second order derivative simply means that you have to find the derivative of this. That is, you have to find the derivative of fx, which is y, which is called dy by dx, as we were doing earlier. So first, let us find the first derivative. This is called first order derivative, which we were finding earlier. This is the first order derivative. So when you differentiate this, x to the power 4 will give you 4x cube. 3x square will give you 6x.
6x.
Minus 5x to the power 1 by 2 will give 5 by 2 x to the power 1 by 2 in the denominator, because it will be x to the power minus 1 by 2. Is it okay?
Yeah, yes, sir.
Now, second order derivative, which is d2y by dx square. When we differentiate dy by dx again, this means we are differentiating dy by dx, which has come over again. So this one will be differentiated again. We will treat it as a function, and so we will get 12x square
plus 6.
plus 6. This will become plus 5 by 4 x to the power 3 by 2, because if you remember, this x to the minus 5 by 2, this is x to the power minus 1 by 2. On differentiating, it will become nx to the power n minus 1. So 5 by 4 x to the power minus 3 by 2. So this will be x to the power minus 3 by 2, like this. Do you understand this?
Yeah.
So finally, this is double derivative. This will be your answer. You can write it. So that means you have to differentiate it, get a value, then again differentiate it, then get a value. That is the second order. If it is third order, that means you will again differentiate, which you have got here. That will be a third order.
Yeah.
So similarly, can you try next one?
Yes, sir, I'll do it.
So you have to do a step by step. First differentiate this, whatever you will get, then
Yep.
there you have to think about differentiating that.
Okay.
Yes, Satya, are you doing?
Yes, sir, I'm doing the second 5x minus 3 pi. Next one.
Okay.
So I'm getting 6 by 4x square
6 by 4x
for the first
square.
derivative.
Okay.
So should I, for the second one, will I be getting, should I do the quotient tool again?
Let me check first.
Okay.
Uh, uh, you are getting, can you tell me?
6 by 4x square.
6 by 4x square. So can we say that this is 3 by 2x square?
So we're not supposed to use quotient tool again?
No, that I will just tell you. Can you first,
Okay, yeah,
can,
canceling, yes, sir.
yeah, that you can cancel now. So it will be, let me see whether you have got it correctly or not. Uh, yeah, correct, 3 by 2. Now it is simply, no need to go to quotient rule. It is simply a term here. Constant will come outside. This is sort of 3 by 2, x to the power minus 2. So differentiate this one. What are you getting finally?
1 minute. So I'm getting 6x by 2. Is that right?
6x by 2. No, you can't get that because when you differentiate it, 3 by 2 will be outside into differentiation of x to the power minus 2 will be minus 2 x to the power minus 2 minus 1. So this will be 3, 2 will cancel. So minus 3 x to the power minus 3. So minus 3 by x cube you will get.
Yeah.
Okay, Sathya.
Yes, yes, sir.
Okay, now you can try the third one.
So I'm getting should I simplify because I'm getting as 2x squared.
1 second. Let me see. What are you getting the first derivative? Can you first tell me the first derivative?
The first derivative, 7 4x cube, 7 into 4x cube plus 3x squared raised to 6.
Okay.
into 12x squared plus 6x.
Yeah, that is fine. Now, this is the first derivative. Second derivative. Here you can, have you started second derivative?
No, I'm going to do it. So just a minute.
Okay, so I will give you a hint. This
Okay.
constant will be outside. This is a u function, and this will be a v function. This is in power 6. Power 6 power. So it is product of two functions.
Do
7
I
is a
do
constant, it will be outside.
the function rule again?
No,
So,
product rule. Not quotient rule, but product.
okay. So, so I'm getting as 7 into 12x whole square.
1 second, let me write. You are getting 7.
7 into 12 x square
Okay,
plus 6x
okay,
raised to the power 6
to the power 6. Okay,
into 12x squared plus 6x.
6x.
Yeah, 6x
Okay,
plus 7 into 4x to the power 3
okay,
plus 3x square
okay,
to the power 6
okay.
into 24x plus 6.
So everything is fine. Only one thing seems to be little. Second part is okay. That is, you have differentiated v. But first part, when you have differentiated u, you have not actually differentiated u. You have differentiated inside it. But ideally, when you want to differentiate this u, what will happen? That it will be 6 into 6 into 4x cubed plus 3x square to the power 6 minus 1. That will be 5.
5.
And then by chain rule, you will differentiate inside one. That will be 12x square plus 6x. So this is whole differentiation of u.
Okay.
Not 12x square plus 6x. This will be 7642 into 4x cube plus 3x square to the power 5 into 12x square plus 6x whole square plus 7 4x cube plus 3x square to the power 6 into 24x plus 6. This is what we are getting now.
Yes, I think.
Written.
Just a minute, sir. Yeah, done, sir.
I'm stopping the share now. You can share.
Yeah. So can you see the screen share?
Yeah. Move further. Higher order derivative can be second order, third order, fourth order, all of them.
Yeah.
Okay, the derivative will always be a slope. This is okay.
So I think, yeah. Selection functions.
Slope of the tangent at a specific so as we already studied before also, that what is dy by dx, what is derivative? It is slope of a tangent. So if a
Yeah.
function is increasing, like you can say that the blue curve is first increasing. So we can say that its derivative is positive. That is a positive slope. Then after crossing a maximum, it is decreasing. Then it will have a negative slope. And at this maximum point, which is between -3 and -2, that is -2.5, it is having zero slope. That is derivative is zero. Then again, it is going down, and then again at a point 1.5, between 1 and 2, somewhere between 1 and 2, it is minimum. So here again the derivative is zero, and then it is increasing. That is the positive slope. That is the derivative is positive. Okay.
Yeah.
Okay. Further, local maximum and local minimums. Okay. Can you go to the previous one? So here, local maximum and local minimum, I'll explain from this curve first. So as the curve was something like this, exact points I don't remember, but the curve is something like this. Okay.
Yeah. Yeah.
So if you see here that this is called a local maximum. This is a local maximum. And this point is called local maxima point. Yeah, X. Similarly, this is local minimum. Now, you can observe that at this local maximum, the slope of the tangent is actually zero. That is, if you differentiate this function f dash x or dy by dx, it will be equal to zero. And at local minimum, f dash x or dy by dx is again equal to zero. Now, how can you differentiate between a local maximum and a local minimum? If we talk about a local maximum, initially the slope is positive. That is, the graph is increasing graph. Then the slope is negative. And if you talk about local minimum, the slope is negative, then the slope becomes positive. So here for local maximum, it is positive to negative, and local minimum, it is negative to
Positive.
positive. Okay.
Yeah.
So this is how we differentiate between local minimum and local maximum. This is the slope. And at exactly the local maximum, it is zero. And at exactly the local minimum, it is zero. So slope is changing sign from positive to zero to negative in case of a maximum, and in case of a minimum from negative to zero to positive.
Okay.
Write this down. Should I stop sharing?
Just a minute, so I'm writing.
Okay, okay.
So can you explain the positive to negative part? What is positive
Yes.
and negative?
Slope of the tangent.
That is positive slope.
Yeah, here it is positive. You see now, if I draw this curve like this, suppose this is a curve. So if you focus on this increasing portion, if you make a tangent at any point on this increasing this point, so what is the angle it is making? Theta. Theta is acute angle. It is less than 90 degrees. So tan theta, which is positive here. Tan theta is actually slope, which is also dy by dx. It is positive. If you take about decreasing part, suppose you are taking this portion somewhere. Here you are taking Q point and making a tangent. So the tangent here is not making acute angle. This is suppose alpha. So alpha is obtuse angle. For obtuse angle, tan of alpha will be negative. So m is equal to dy by dx here will be negative. So this is how we understand that it is a maxima. In case of minimum, initially the slope is negative, then it is positive.
Okay. Yeah, I think I understood.
Getting it?
Yes, sir.
Okay, you can write this below part also, which we have discussed just now. If you want to understand it more, I will just explain it more. Like you can think it of like this also. Slope of a tangent, what it actually means, this is a curve like this. Okay. Now this is a point. Suppose this is a point P. and you are making a tangent here. So tangent is actually sort of a chord. So you are joining 2 points and you are taking this as delta y, this as delta x. That will be too much in detail. It is not needed. Leave it right now. We have done this thing, but leave it right now. Understand till here.
Yeah, I
We will
understand
again
this.
go back in the basic. Yeah.
I am done writing.
Okay. Yes. Next page. Next page. Okay. Next page. Done.
No, sorry. Yeah, yes.
Okay. So go back to the previous one. The
Yeah.
back again back. Okay. Back. Hmm. So yeah, let me take the pick of this. So here the example is a function fx is given, that fx is x cube minus 6x squared plus 9x. And the graph of fx is on the right side. That is like this. This is 3, 2. So it is like this. Okay. So here this is the graph of this function and this is the equation of this function. Now the first we have to find f dash x graph, f dash x graph and f double dash x graph on the same this graph paper. So first point says f dash x will have x intercepts at all turning points of fx. So it is an important point. Let's try to understand and remember these points. First point is saying f dash x will have x intercepts at all turning points of fx. So what are the turning points? There are two turning points. One is x is equal to 1 and x is equal to 3. Can you see this graph being getting turned? Like this is going like this, and at 1 it is getting turned, and at again 3 it is getting turned like this. Isn't it so?
Yes, sir.
So these 2 points it is getting turned. These are the 2 points where the derivative graph will have x-intercept. That means it will intersect the x-axis. Okay.
Yep.
So we'll do that. Next is f dash x, which is the derivative, must be quadratic as fx is a cubic function. Fx is a cubic, as you can see that x cube is the maximum power. So the differentiation will be quadratic, that is x square will be the maximum power. You can just differentiate also, like x cube minus 6x square plus 9x, x cube minus 6x square plus 9x. This is what we have. And then we differentiate it. What will happen? 3x square minus 12x plus 9. This is what we will get. So this is a quadratic. This is a cubic, and its differentiation is quadratic. Now, another point is we can take the derivative and find several points to estimate the derivative. So let us estimate several points here. 2 points I'm estimating. You can estimate more than 2 points also. Like I'm taking x equal to 0. So f dash x will be 9 when you put x is equal to 0 here everywhere. Next I'm putting, let us say x is equal to 1. So when you put x is equal to 1, this will be 3 minus 12 plus 9, it will be 0. That means 0 comma 9 is 1 point through which it is passing, and 1 comma 0 is another point through which it is passing. Are you getting till here, Sathya?
Yes, sir.
So 0, 9 and 1, 0. Now
Okay.
0, 9 will be somewhere here. This is 0 comma 9 y-axis,
Yeah.
and 1, 0 is here. This point is 1 comma 0.
Yes, sir.
It has x-intercepts at all turning points. Turning points are this 1 and 3. Turning points of fx 1 and 3. So there it will intersect. So from
So
here,
what is the
but
point at 3?
it is a turning point. No?
Okay. Yeah.
At 1 also it is a turning point. It is turning. The function is turning. And 0 comma 9 it is passing. So when we draw the graph of this, it will be something like this. It will be like this. So this is
Okay.
the graph of f dash x. So first write till here. Then we'll
Yes, sir.
also draw the graph of f double dash x.
Yeah, done, sir.
Okay.
Done, sir.
Okay. Now we have
Yes, sir.
done now.
Yeah, yes, done.
Okay. So now we have to find double derivative. So double derivative graph means you differentiate this f dash x again. So that would be f
So
double dash x.
we differentiate 3x squared.
Yeah. What it will be?
Okay. That'll be 6x minus 12.
6x minus 12. This is called linear.
Linear. Yes, sir.
That is the power is 1. So here also what we do, this will be a straight line. So we can put x is equal to 0 and the f double dash x will be equal to minus 12. And when x is equal to suppose 1, it is minus 6. Point is 0 comma minus 12 and 1 comma minus 6. It is 0 comma minus 12 and 1 comma minus 6
Yeah.
here. So this will be a straight line which will be going like this something. So this is f double dash x. Yes. Should I scroll down?
Just a minute, sir. So you can scroll down now. I think I drew the graph. Yeah, done, sir.
Now you can just share. This is what we got.
Yes, sir.
Now we can move further.
Now we have the applications.
Okay. What does the slope of a position time graph represent? So let me take the pic here. So position time graph, that is the derivative of position with respect to time. So if you see this figure here, position is given, time is given. And this is like this. Then from here it is like this, and it is like this. A point, B point, C point, and then D point. So what is the speed? Speed is distance by time. Or if you talk about velocity, it is displacement by time. Is it okay?
Yeah.
So let us talk about velocity, because here position will be having a direction also. So if it is moving from A to B, so slope of this graph, this portion, this is the slope. This is actually velocity. So velocity is actually positive. It is, slope is positive. Velocity is positive from A to B. Velocity from A to B is positive. That means it is moving in positive direction. Okay, in a direction where the position is increasing. Then velocity from B to C is also positive, because the tangent there is uh, is having positive slope, but this slope is less than that. So we can say velocity from B to C is less than the velocity from A to B, because this line is having slope tan theta, which is greater than this line, which is having slope tan alpha. So this is more steep, na? This blue one here is more steep than the black one. So we can say the velocity from B to C is less, and velocity from A to B is more. Is it okay?
Yes, sir.
Now velocity from C to D. So the slope here is actually negative. It is a negative slope. So that means
Yeah.
it is moving in the opposite direction. So the direction is opposite from the normal. Like if an object has to move, or if a car has to move from a position uh, home to position work, so that is, positive velocity will be as it gets closer and closer to the work. If it is moving just opposite to it, then it will be a negative velocity. So this is what we will say from here, that simply the tangent or the slope represents the velocity, and velocity is positive, and then velocity is negative.
Yeah. Sir, so AB is positive, BC is positive, and only CD is negative.
Yeah.
So then what does the slope represent?
Slope is basically the derivative or the tangent of the angle. That is, this is the angle here. So it's tan theta. This is theta. Its tan theta is actually slope. That is a steepness.
Okay.
Similarly here, this angle is theta. Similarly here, this angle is theta.
Okay. Yeah.
Just as a common English, you can just say that if there is a hill with with greater slope, that means it is more steep. If a hill is having less slope, then it is less steep. If it is a negative slope, that means you are going down the hill. If it is a positive slope, that means you are climbing up the hill.
Yes, sir. Done, sir.
Okay, done. Okay. So here it was not a detailed analysis required. It was just that the position slope of a position time graph represents the velocity and it's whether it is positive or negative. That's it. Okay, let's move further. Derivatives have many useful applications in real life. Given st, a position function, s dash t represents the respective velocity function. Furthermore, okay, so position function st when differentiated give you velocity function vt, and velocity when differentiated it gives you acceleration. So rate of change of position is velocity and rate of change of velocity is acceleration. That is, sometimes it is said na, this bike or this car has a very good pickup. What pickup means? Pickup means acceleration, rate of change of velocity. Pickup generally means in that sense. Velocity means another thing, like a car or a bike can attain a maximum speed of 156 kilometer per hour. That means it's velocity, maximum velocity. So that is velocity. But another thing is acceleration. So a car may have highest velocity may be very good, but acceleration may be low, like its pickup may be low. For example, it is changing its velocity very slowly, and some car may have the velocity low, highest maximum velocity, but the acceleration may be very good, like it is changing its velocity very, very fast, right? Like a sports bike and all, they have a very good acceleration. Pickup is very good. So rate of change of position is velocity, and rate of change of velocity is acceleration. So when you differentiate position, you will get velocity. When you differentiate velocity, which is you get acceleration. That means double derivative of position is acceleration. Okay.
Yeah.
So further, given the position function, answer the following question. When is the object moving in the positive direction? The negative direction? What is the action of the action? Should describe it, but that's okay. So can you try it once? Then we'll discuss.
Sure, sir.
I'll taking pick of this. Yeah, just try it once, then we'll discuss. Are you trying it, Satya? Can we discuss?
Yes, sir. So for the
Okay.
first one, should we derive derivate?
Yeah, differentiate.
So yeah, differentiate the first,
Okay.
and then how do we get the negative direction?
So after differentiation, what you are getting?
1 minute, sir. I'm not done with that. 9.8 t plus 20.
Okay. So this is derivative of position. So what will it be? It will be velocity, right?
Yeah.
Derivative of position is velocity. So they are saying when is it moving in positive direction? So when it will be positive, so greater than 0. So 20 is greater than 9.8t, you will say.
Yep.
So you will say 20 by 9.8 is greater than t, or you can also say t is less than 20 by 9.8, or you can say t is less than 9.8, 2 times is 19.6, then 40, then 19.4. This will be, let us divide like this, 200 by 98. So 200 by 100 by 49. So 100 by 49 will be 49, 2 times is 98, 2, 0. After decimal, then 0, then one more 0, 4 times. So 196, roughly 2.04. So you will say that for time before 2.04 seconds, it is in positive direction. It is moving in positive direction. And after 2.04 second, it will move in negative direction. Is it okay?
Yes, sir.
This we did earlier also. Na? This here, velocity from A to B was greater than 0. That was the slope. That is the derivative. So here also, when you find the derivative, you will say it is greater than 0. So time you will get here less than 2.04 second. And after
Yeah.
2.04 second, it is will mean negative direction. This division also you will see. This is how we will divide. 200 by 98 is equal to 100 by 49. This is actually 20 by 9.8, which is 200 by 98. And then do the division. This is the division part. Written, Sathya?
I'm writing such. It's answer.
Okay. Now you can share.
So, but there's two more questions.
Sorry.
There's B and C.
Mhm. So what is the acceleration of the object?
We
So velocity is derivative of position and acceleration is derivative of you can see back also previous slides. If you want to consult previous. Yeah, previous to this. Yeah, here.
so position velocity function derivative. So we just derivate 9 point.
Differentiate. If you are
Sorry.
using the verb, then it will be differentiate.
Okay. So we differentiate 9 point t,
Minus
9.8 t
9.t.
minus 9.8 t plus 20.
Yeah,
So that will only be 9.8, right?
minus 9.8.
Yeah.
So that will be minus 9.8 will be the acceleration, meter per second square.
Okay.
This is actually the acceleration due to gravity, if you remember in physics.
Yes, sir. 9.8 per second.
Hmm. Meter, uh,
Meter per second.
meter per second square.
Is it per
Ac-
second square?
yeah,
I think second.
acceleration is meter per second square.
Okay. So minus is like moving downwards or
Minus is moving downwards. So acceleration is minus means the pull is towards downward. Pull is towards the earth. Object is being thrown up, but pulling is done by the earth. So once, so if you try to understand it, what is happening, just see here. I'm explaining it to you. What is happening that the object is being thrown like this from ground,
yes.
and this ball or something goes up at at t less than 2.04 second. That is at the top, it is 2.04 second. This will stop and then it will come down to the ground. So before 2.04 second, the direction of the velocity is up. That is why it is coming out to be positive. And after 2.04 second, the direction of velocity is downward. That is, it is negative. Acceleration is always negative. Velocity is here positive, upward. Velocity is here negative, downward. Acceleration is always negative, which is minus 9.8. You are getting acceleration as minus 9.8 meter per second square. So this is always downward. So if you see the direction here, so the direction v is greater than 0 till t.04 second. After t.04 second, it is less than 0. It is coming downward, the ball. And acceleration throughout, which is gravity acceleration due to which is less than 0. That is minus 9.8 meter per second square. Are you understanding this application?
Yes, sir.
Now, what is the last point?
At what time does the object come back to its original position?
Okay, so the displacement is 0. Now it is saying the displacement is 0. So what was the equation of the displacement?
Is it 2 point?
Yeah, you
The
can say that also. What are you saying? You can say
2.04, right?
it will be at the top. And another
Okay.
2.04 it will take to come to the bottom. So it will be 4.08.
4.08.
This will be C. This will be written.
Yes, sir.
Now you can share. So let us do till here today. Let us see what else is remaining anyhow.
Yes, sir. I think that's it, sir. That's the last.
Okay, that is the last. Okay. Okay, fine. So you can do the assignment now based on this.
So let me share this. Can you see the screen share?
Yeah, yeah. So this you will do later on your own, you will do it. Okay.
Okay.
Or we can do tomorrow also.
So then we'll continue the next topic.
Yeah, I think today we can keep till here only. Okay. Because I have another meeting after some time. So I thought
Okay,
it is 1.5 hour today. So let us keep it for this time today. Tomorrow we'll
okay, sir.
continue. You can try the assignment on your own, and
Yeah,
we can discuss, or we can try together also. You can see the videos in the meantime.
yes, sir. I think this is the next
So
topic, curve sketching.
curve sketching and the first derivative. Okay, this is not what we have done just now.
So, this, I
Okay,
think,
okay. Yeah, this one. Correct. Fine.
so do you want me to open it fully?
No, it is visible here. No issue.
Okay.
You can just slide it. Critical points, intervals of increasing, decreasing. So you want to do it now?
No, so you told you have another meeting, right?
Yeah, that's right.
Yeah.
I
So
uh,
wait.
I got it from the topic. I understood what it is
Yeah.
all about. So tomorrow we will definitely see this. Okay.
Okay, sir.
Tomorrow again we may have 1.5 hour or 2 hour class. So we will see what we can do
Okay,
maximum.
sir.
How was your exams and all?
It was hard. It was very hard, sir.
Okay, in this course only you had
Oh, this one, this exam?
the exams you have yesterday, a day before yesterday, all those exams. You were
Oh, so
having
that was
exams.
from school, pre-board.
Okay, that was pre-board. So how was that going?
Yeah, it was not easy. It was very hard, sir.
Okay,
I had chemistry. And one day I think I'll have physics.
okay, Monday you have physics. So anyhow, if it is a tough exam in school, still it is same for everyone in the board. So you don't have to worry about it a lot. Just
Okay,
try to give your best and prepare as much as you can.
okay, so yeah.
So how was it for other students?
Yeah, for everyone it was hard, sir. I think
Okay,
many people who get good marks, they told it's hard. They're only expecting,
okay,
I think, 40 out of 70.
okay. Okay.